Hi everyone, so this will be chapter 3 revision quiz, a review of chapter 3 revision quiz. So based on the responses, we will discuss question 1, question 16 and question 17 since these three questions received the most responses. So question 1, an object of mass m is dropped from rest. If you see the word drop from rest. Okay, drop from rest means by it starts with u equals to 0 ms negative 1. Okay, from a height h. Okay, from a height h. Means by, since it's drop, we know that sy will be negative h meter since it's going downwards, so it's a negative sign. Okay, so as it strikes the ground, the object imparts an impulse to the ground with a magnitude proportional to what? Okay, so to make it slightly clearer, I probably need a diagram. So you have something like an object here. This object initially it's at rest, then it's being dropped. Okay, this is what you need to recall from your knowledge. When something is dropped, there's only gravity acting on it. That's why the acceleration is negative 9.81 meter per second square. Okay, AY to be more specific. Okay, so when it approaches the ground, it will have a final velocity. When it's approaching the ground, you have a final velocity which we are not sure. Okay, when before it hits the ground, okay, this is the final velocity right before it wants to hit the ground. Okay, but we also know that this question talks about impulse. If we talk about impulse, we know that this collision will be our event. Okay, it will be our event. So as I said before, you need to look at the before the event, and you need to look at the after the event. What are the velocity? Okay, I'll put a prime to differentiate from the free fall. Okay, this is regarding a collision, so I put a prime here to show that it's another situation we are talking about. This u here is different from the u equals 0 per ms, 0 meter per second. This u prime is different from the u, which is now equals to 0 meter per second. U prime has a different value. After you have v prime, and you know j will be equals to m v prime minus u prime. So this is the impulse that is imparted by the object to the ground. Okay, so by the object to the ground, it's negative, but we don't really care about this. We just want to know about the magnitude. So I'm going to use this. This is the impulse imparted by the ground on the object. Okay, but never mind, we only care about the magnitude, so the sign we don't really care much about it. We know that j equals to m. We know that when this thing hits the floor, it will not bounce back. Okay, so once it hits the floor, the final velocity will be 0. Whereas the initial velocity, which is the velocity before it hits the ground, will be the final velocity when it nearly hits the ground. The final velocity where it nearly hits the ground will be the initial velocity of the object before it hits the ground, which is our collision, before it collides with the ground. So we know that this one will be minus And from here we know that this thing and this thing are the same thing. And therefore we know that it's m0 minus v. Okay, then we know that j is equals to negative mv. Okay, until this part, it's all what we have learned before. So this is the impulse by ground on the object. Okay, you know that it's by ground on the object because this value v here will be a negative value since it's downward. And since you know the v will be a negative value, multiply with something positive and multiply with something which is negative. The negative here, you get a positive impulse indicating that it's upward. Okay, it is by the ground on the object, but the question asks for impulse to the ground. It means by it's asking for by object on the ground. So in this case, we need to flip a bit. Our j, okay, will be equals to mv instead. Just now this one is by the ground on the object. Now this one is by the object on the ground. Okay, so knowing this, we can start to see what is it proportional to. We want to find mv is proportional to what. Okay, the v here comes from here. So how do we get this v? We know v, we know a, we know u, and we have this distance to be h. A suitable formula to use here will be v square equals to u square plus 2as. And since u is equals to 0 plus 2, it's negative 9.81 for a. And we have our s, it's a displacement downward, so it's negative h. Combining all these things together, we will see that v square will be equals to negative 19.62. Together with this negative, you get a plus h. Okay, so you know v square is equals to something times h. Therefore, v will be proportional to square root of h. And therefore, knowing that v is proportional to square root of h, we can continue here to say that it's proportional to m of square root of h. Therefore, the answer is m square root of h. Okay, the question is a bit complicated, but it's a combination of chapter 2 and chapter 3. And if you know these two chapters solid, then you should be able to relate them with something like this. Okay, so next question, question 16. Question 16 says that consider two cards of masses m and 2m at rest on an air track. So you have two masses. Okay, I'll call it m1. m1 has a mass of m, whereas m2 has a mass of 2m at rest on an air track. At rest on an air track means, right, initially Both of them are 0 meter per second. 0 meter per second. Now, knowing this, we can continue the question. If you push each car for 3 seconds, means by push the first car for 3 seconds, and you push the second car for 3 seconds as well, then your force 1 is equals to force 2, because they say equal force on each. Okay, so they are asking for the momentum of the light car after the push is what than the heavy car. So what we want to know is the PF of the light car. The light car is 1, right? Compare to the momentum final of the second car. Okay, we know that to know the final momentum, we can take its equivalent to getting the initial momentum plus the change in momentum of 1. Okay, for our case number 2, it will be the initial momentum of the object of car number 2 plus the change of momentum experienced by car number 2. But we know that change in momentum is equal to impulse. Okay, change in momentum equals to impulse. This one, change in momentum will be equals to impulse. And we know that impulse is equivalent to F1 T. Whereas the next one will also be 2 F2 delta T square. Delta T 2. Okay, so let's look at what we can do here. If you see here, P momentum initial for 1, is it the same with momentum initial for 2? They should be the same, because if you look at the initial momentum is m1u1 and m2u2. Both of them have 0 velocity at the start. Therefore, both of these cars have initial momentum of 0. Car number 2, the initial momentum is also 0. Okay, now if you look here, F1 is equals to F2. Can relate it here. Then T1 and T2 are both the same. Knowing these two things, we can safely say that they are equals to 1. If we know that they are equals to 1, we can say that PF1 equals to PF2. Therefore, the final momentum of the light car and the final momentum of the heavier car, they are exactly the same. Okay, so this is how you solve a ratio problem. You do it by setting a case 1 and case 2 and list down all the variables. Then you can compare between final 1 and final 2. This is how you do a comparison, by taking a ratio between two cases. By knowing that they have the same initial momentum, which is 0, the same initial momentum, we know that they have the same force, we know that they have the same time of impact, everything is the same top and bottom, therefore you get 1. So you move around this equation, should find out that final momentum 1 is equals to final momentum 2. So that's the idea for question 16. For question 17 is the exact same question, except that now your energy of the light car. They're asking for the energy of the light car comparing to the energy of the heavier car. So now I believe this energy here is the kinetic energy. So we can say that the K, case 1, divided by the K of case 2. So we know that it will be half m1 v1 square. So the next one will be half m2 v2 square. Okay. So we know that 1 and 2 have the same momentum. Same initial and final momentum. Okay, and we also know that since K is equals to half mv square, you can also express it in terms of P square over 2m. This P here is of course mv. Okay, if you do the maths, mv square over 2m, you see that is equivalent to m square v square over 2m, which is basically just half mv square. So if I express it in terms of p square over 2m, then things will be a bit easier to explain. So for this one, it will be p1 square over 2m1 divided by p2 square over 2m2. Okay, we flip things around, so it will be p1 square divided by p2 square times 2m1 divided by 2m2 divided by 2m1. Okay, it's mathematical manipulation, but just now we said that P1 is equals to P2. This one is from previous question. Therefore, we can know that this and this will cross out to be 1. This and this can potong, so we are left with m2 over m1. We know from up there, m2 is 2m, m1 is m. And therefore, the answer is 2. Okay? The answer will be 2 times greater. Okay, it involves a bit of ratio calculation, which I think is an important skill. So if you're comparing energy, you take energy in one case, divide by the energy of another case. After that, you need to continue to do some kind of substitution here and there to obtain the correct answer. And for this case, the correct answer is 2 times greater. Okay, so that's all for chapter 3. Thank you.